What is up, guys? This is Weasel for PokerWeasel.com. Welcome to part 4 of the Core Maths series. Today we're going to be talking about reverse implied odds. Okay, so coming up in this episode. Firstly, what are reverse implied odds? We might as well start by defining our term. As we're going to see, they're very similar to implied odds. They're basically the reverse of implied odds. Reverse implied odds, the maths. We're going to do some maths. We're going to do the same maths we did for implied odds, but we're going to do it for reverse implied odds. This is something you just never see in any training video anywhere. I don't think there's a single book out there or a single training video that deals with how to calculate reverse implied odds. You'll find resources that tell you what reverse implied odds are, but they won't actually do any reverse implied odds calculations. So very likely this is the first training content that's actually going to do a real reverse implied odds calculation. We're going to talk about common scenarios where reverse implied odds are generated. So one of those scenarios is going to be draws, in particular dominated draws, and the other common scenario is going to be mid-strength made hands that don't improve very well. So there we put pairs. We're going to have a look at an example of in which situations would a pair suffer from reverse implied odds. We're going to elaborate on those situations a bit further. We're going to give you a method for estimating what your true pot odds are in a situation where you have a pair that suffers from reverse implied odds. So the idea here is that the pot odds you're being offered don't really represent the true price you have to pay in order to see a showdown. So we're going to talk about how we can make some adjusted pot odds calculations based on the fact that we have a hand that's very vulnerable and is not going to stand up well to action on the later streets. We'll have also a common pre-flop example. The examples we'll look at with the draws and the pairs are going to be post-flop examples. I think it's useful to have a look at a common pre-flop example, and the example we're going to look at, it's going to involve a misconception that apparently even some high-profile poker players don't understand. It's actually something that should be very simple. It shouldn't be very advanced, but even in recent media, there has been examples that indicate that even some high-profile poker players don't understand this common misconception regarding reverse implied odds. So then, as usual, we'll summarize the concepts and review the things that you should have taken away from this video. So let's start at the beginning. What are reverse implied odds? As mentioned, reverse implied odds are the opposite of implied odds. So just to recap, the idea of implied odds is it doesn't matter if we don't get the direct pot odds on our current street, because we stand to make a lot of chips on the later street, which more than make up for the fact that we may not be getting the direct odds on our current street. Reverse implieds is the opposite. We actually stand to lose chips on later streets. What that might mean is, even if you do get the direct pot odds on your current street, it still might not be correct to call, because you're going to end up losing money on the later street, which is going to make it non-profitable for you. In other words, you can have the direct pot odds, you should still fold, because if you call, you're going to end up in some really risky situations on the later streets. It's going to be better that you fold on your current street than it is to proceed to those later streets and end up losing additional chips. So in the same way that when we have good implied odds, we can get away with having less than the required pot odds, in a situation where we expect to have reverse implied odds on the later streets, we actually need more than the required direct pot odds. In other words, if you have exactly the right pot odds in a certain spot, but you estimate that you will actually lose money on average on the later streets, then it means you can't defend. So essentially it means you're going to need more than the required pot odds to make up for the fact that you're going to lose additional chips on the later streets. Now it's best to illustrate this perhaps with a graphic, and what I really want you to understand from this is that implied odds and reverse implied odds are not separate things. It's not possible, for example, to have both reverse implied odds and implied odds in a certain situation. These terms are simply two opposite ends of the same spectrum. So in a situation where you have good implied odds, it means you don't have reverse implied odds. You can't have both of them. In a situation where you have reverse implied odds, you can't have implied odds as well. You either have good implied odds or you have reverse implied odds. Now to illustrate this with a graphic, if you look there on the vertical axis, the y-axis, this is going to measure our pot odds. So if we are exactly halfway along that line, and this is not drawn to scale by the way, you can probably tell, but you see where that horizontal line is, halfway down the y-axis, that means that we have exactly the right pot odds to call. Now in a situation where we have exactly the right pot odds to call, we don't need any implied odds to make it profitable. It's going to be break even. And whether we need implied odds or not, that's represented by this diagonal blue line. So in a situation where we don't get the right pot odds, i.e. below halfway on the y-axis, then we need to make up for that with implied odds, and that's represented on the x-axis over the right hand side. So you can see exactly halfway on the horizontal axis is the point where we neither have implied odds, but we don't have reverse implied odds either. If we go towards the right hand side of the x-axis, that's a situation where we have implied odds. We stand to make money on the later streets. Over on the left hand side of the x-axis, we have reverse implied. We stand to lose money on the later streets. So if you have a look at where that diagonal blue line is over on the left hand side, you can see that in order to make a call in a situation where we have reverse implied odds, we need better than average pot odds. So if you ignore the fact that this is not drawn very well to scale, and these lines aren't appearing exactly halfway across the axis, hopefully you get the general idea of the relationship between reverse implied odds and implied odds. They're not different concepts, they're the same concept, they're just different sides of the same coin. So if you understand this graphic, and it shouldn't be too difficult to conceptualize or understand what's going on in this picture, if you understand that, then you have a basic understanding of how reverse implied odds works. It's exactly the opposite of implied odds. Now we're going to do some maths. This is something that's just never done in any training video or in any book. I'm not sure what the reason why is. The only reason I can come up with is that it's just not fashionable, i.e. it's just not something that's commonly done. There doesn't have to be a reason for that. Maybe it's just that it's not fashionable to think about situations where we might lose money on later streets. Perhaps most poker players are optimists and assume they're always going to make money on the later streets, whereas that's not really how poker works. And in some cases, the fact that you're going to lose money on a later street doesn't mean that you can't continue on your current street. That's exactly why we want to do this maths. We want to gauge the impact of our reverse implieds on later streets to see if we can still defend profitably on our current street, despite the fact that we're going to lose chips on a later street. Let's see a very basic example. And firstly, just understand that everything is identical to pot odds. And it's identical to implied odds as well. In fact, pot odds is just the same as implied odds and reverse implied odds as well. It's just that pot odds doesn't take into account any future action. But in terms of the calculation you're going to do is exactly the same for reverse implied, pot odds, and implied odds. We consider the percentage of the total pot we are investing, and it's just that when we say total pot in the case of implied and reverse implieds, we're also projecting the pot size to include our profits or losses on the later streets, whereas pot odds just looks at the size of the pot on the current street. So if you remember the way we did implied, we factored in that additional chips we'd make on the later streets. Well, with reverse implieds, we still do that, it's just that now we're going to be using a negative number. The size of the pot on the later street is going to be effectively reduced because we're going to be losing chips, whereas in the case of implied odds, the effective size of the pot was increased because we factored in those additional chips we can make on the later streets. So exactly the same maths going on here. Maybe that's another reason why this is not commonly done, because it's just very easy to say, well, the maths for reverse implied is the same, so we don't really need to look at that again. But I think it's very, very interesting to try and do everything in reverse. It really gets to test you to see if you understand on a very good level the concepts involved, because it's very easy to understand the formula for things. But what you'll probably find is when you try and engage your brain here to do everything in reverse, you'll find that certain questions are going to pop up that didn't really occur when you were trying to calculate implied odds. Maybe this will happen. You'll see what I mean if it does happen. So I'm going to leave you with a question for you to try and figure it out. And see if you get stuck at any huge roadblocks where you're just somehow finding yourself thinking about the entire game of poker and trying to figure out reference points and things like that. Maybe this will or maybe it won't happen, but there's a possibility it does. And I think that's in itself a very, very good reason to do this exercise. So let's have a look at the exercise. We hold a dominated draw out of position on the turn. So right off the bat, if you have a dominated draw, those are the kind of hands that are going to mean you have reverse implied odds for the later streets. Because the idea is you have something like a 6-high flush draw, or you have a flush draw on a paired board, for example. You're going to make your flush, but even when you make your flush, you're not going to be sure whether you can call off a big bet on the river. In general, you certainly can't raise in those spots, so already your implied odds gets completely killed, because if you had the nuts, you'd be raising on the river, for example. But in a situation where you have a dominated made hand on the river, your decision is now, should I call, should I fold? And what's going to happen is, you're very often going to lose money on average. It's not going to be a situation where you have very good implied odds. So we have one of those hands, we're on the turn, a dominated draw out of position. Let's say we're going to hit around 30% of the time. You have something like a dominated combo draw. We've seen examples of this when we discussed odds and outs a little bit earlier in the series. So you have maybe 15 outs with a dominated combo draw. We're going to hit about 30%, but our outs are not very likely to be good. It's going to be a bit problematic trying to figure out whether we should call a river. So here's some numbers. There's $100 in the middle, and our opponent bets $30. Okay, so he's betting pretty small. So ordinarily we might just go ahead and fold that dominated combo draw, but all of a sudden our opponent's giving us this really good price, and we're thinking, okay, can I really still fold to a $30 bet? Let's say we just know, and this is something that you can practice trying to estimate, but it's a little bit harder trying to estimate things in reverse. It's one thing trying to estimate how much money you think you're going to make on a later street, but it's a completely different thing in its entirety trying to estimate how much money you're going to lose on average on a later street. But let's just say we know that if we do hit our hand, we're going to lose about $50. So the next thing you're probably wondering is, well, hold on. If we don't hit our hand, how much do we lose? And the answer is, we don't lose anything if we don't hit our hand. So this is the point where your brain might start reacting badly, and you possibly spend the next half an hour thinking about reference points. So hold on, how can it be that if we hit, we lose $50, but if we don't hit, we don't lose anything? It's very, very strange. And the answer is to do with reference points, by the way, because the idea is we don't really lose $50. What we're really saying is, we're going to win what's in the middle minus $50. Whereas if we don't hit, we actually don't make anything at all. So in some senses, we're not really saying we're going to lose $50. We're just saying that we're going to make $50 less from the total that we would make if we currently won everything that's in the middle, in the pot. So just think of it that way. We're going to lose $50, but in some senses, we're not really losing $50. We're still making money. We're just not making everything that's currently in the pot, because we're going to lose money on the later streets when we hit. So here are the questions you have to answer. Is the call still profitable? That's the first thing. Do we get the right price to call here, factoring into account our reverse implied odds? I mean, one thing we can see right away is that we clearly get the direct pot odds here, because we're going to be investing about 30 into a total pot of 160. If you just look at your direct pot odds, it's clearly going to be a very profitable call. But now when we factor in that we won't make the full pot size, essentially, we're going to make $50 less, is the call still going to be profitable? So that's the first thing that you have to try and answer. Question number 2, regardless of whether the call is profitable currently, how much can we afford to lose on the river or on the later streets? So is it okay to lose $50? Can we lose more than $50? What's the exact point where we have to say, now we're breaking even, but if we lose any more than this on the later streets, we now have to fold on our current street? Well done if you're keeping up with this, by the way. Even if you are currently an advanced and high stakes player, there's a good chance you've never done this maths before, so it might have a tendency to run your brains around in circles a little bit. But what I recommend you do right now, pause the video, try and answer these 2 questions. When you have an answer, or you don't have an answer to these questions, but you've given up, then proceed by watching the video. We're going to answer both of these questions right now. This doesn't have to be complicated. It's actually very, very simple. It's just that your brain might start to play tricks on you, given that you've probably never done this maths before. So, there's 100 in the middle, and our opponent bets 30. We expect to lose around $50 on the river if we hit. So, question 1, is the call still profitable? Well, if we look at our direct pot odds, as mentioned, we're investing 30 into a pot of 160. But given that we're actually going to lose $50 in later streets, we're now effectively investing $30 into a pot of 110. Very, very simple, right? In the case of implied odds, we'd add that value to the total pot size. Here, because it represents losses, we're going to subtract that from the total pot size. So instead of a total pot of $160, it's now going to be a total pot of $110. So next we do 30 divided by 110. Let's just check some of this maths as we go along. 30 divided by 110. Hopefully you're very familiar with this method by now. And if you still need to do this step, but you don't have to, you can multiply by 100. 27.2% equity to make the call. Now just contrast that to what our direct pot odds tell us, which is 30 divided by 160. And again, you can times by 100 if you want. According to our direct pot odds, we only need 18.75% equity. We only need to hit 18.75% at the time. So if you did just look at your direct pot odds in this situation, you wouldn't be getting the full story. Because when we take into account the fact that our hand is heavily dominated when it hits and stands to lose additional money on the later streets, we actually need closer to 30% equity to make the call in this spot. Or when I say 30% equity, what I really mean is 30% chance to hit our draw, 27.2% chance to hit our draw. Now the idea here is, despite the fact that we have reverse implied odds, if this number's accurate, if we lose about $50 on the river after we call a turn, what that means is if we have that ability to hit on the river more than 27.2% of the time, we should still make the call, despite the fact that we're going to lose money on the river. It's still going to be profitable to do that. So this is why we run these calculations. We know that having reverse implied odds is not favorable, but there are still situations where, despite the fact that these reverse implied odds exist, we can still make a profitable defend. So in this case, we need at least 27.2% equity to make the call. We said we're going to hit about 30% of the time. So I'm using how often we hit an equity interchangeably here, which is not necessarily 100% the case. But we've said we're going to hit about 30% of the time. We only need to hit 27.2% factoring in our reverse implieds. We have to make the call here. It's a profitable call. So now the question is, if losing $50 on the river still allows for a profitable call, how much can we lose in order to break even or for the call to still be profitable? So just to see the maths there again before we move on. So we're investing 30 into 160 according to our direct pot odds, and hence only need 18.75. See, there's a big difference between those two numbers, 18.75 and 27.2. So it's very important you factor in these reverse implieds. Moving on to the second question. So here's the question again, 100 in the middle, our opponent bets 30, and we lose around 50 on the river. Question 2, how much can we afford to lose on the river? Well, we know that given that we're going to hit about 30% of the time, we can't invest more than 30% of the pot. Again, hopefully you've picked that up from the early videos as well. So let's just imagine that $30 represents 30% of the total projected pot. How big would the pot be in that case? Well, it's pretty easy, because if $30 is 30%, then the total pot must be $100. Now, given that the pot is already $160, we can hopefully figure out from that how much are we allowed to lose, and yet still the effective total pot remains at least $100. Well, it's very simply 160 minus 100. We must be allowed to lose $60 and still break even. Let's just run through that maths again. So $30 has to equate to 30% of the total pot, because that's how often we're going to hit our draw. The total pot factoring in our river losses would be $100. If we assume that we're investing exactly the right amount according to our adjusted pot odds, factoring in our losses, then we know that the total pot would be $100. We can hence afford to lose $60 on the river and still break even. So hopefully you can see everything is exactly the same as what we discussed in the video on implied odds. We're just doing things in reverse right now. It's very important that you identify scenarios where you are likely to have reverse implied odds. Because if you don't realize that you're likely to have some reverse implieds, you're not even going to be doing any calculation. So the first important step is understanding which situations generate these reverse implied odds. When you really break it down, there's generally two types of situations, at least post-flop. We're going to see a pre-flop example as well a bit later. But post-flop, there's generally two types of situations which generate these reverse implied odds. The first is having a dominated draw. So I'd like you to imagine the following. We're not going to use too many specifics in terms of stack sizes and bet sizing and stuff like that. Basically, we're out of position on the turn, and we're facing a second barrel. So we're probably the cold call at pre-flop. Our opponent c-bet the flop, we've called. He's fired again on the turn. Let's have a look at the board texture. So we have 5-6 of hearts. Flop was king 6-8 two-tone with 2 hearts, and the turn is an 8 of clubs. So our opponent is betting again. Now I'd like you to imagine, just so you can see how this works, that we're getting very, very close to the pot odds. In fact, let's just say we get exactly the right pot odds. That means he would be betting pretty small here. He'd be betting less than half pot. So he's making a very, very small bet. I'm looking at the situation and we figure out that we get exactly the right pot odds to call. Now, when I say exactly the right pot odds to call, what do I really mean by that? Well, I just mean if you look at the number of outs we have, ignoring whether they're clean or not for now, we have 9 outs because a heart gives us a flush. So we're going to hit maybe about 18% of the time going to the river. So I'd like you to imagine that you get the right price assuming that we hit 18% on the river. Now it would be a mistake if we were to assume that because we get exactly the right price we're breaking even. In fact, it's going to be a losing call overall. Because what is the problem with this board texture? Well, we have a couple of big problems. Number one, the board's already paired. What that means is we might just be drawing dead right now to something like pocket 8s, pocket kings, pocket queens, king 8, queen 8. We can't improve to beat these hands, so we could literally be drawing dead. Also, even if we're not drawing dead right now, our opponent could have something like a higher flush draw. So we could make our flush, maybe he doesn't have a boat, but he just has something like ace-10 of hearts. Once again, we're in big trouble. Because what will happen is we'll hit, and although sometimes we'll be good on the river, it's very, very difficult to extract a lot of value from our opponent because we're always aware of the fact that he could have something better than our 6-high flush. So it's not like we can just raise his river bet, he re-raises, we re-raise, and we just get a whole bunch of chips in. That's going to be a disaster for us because by the time a lot of chips go in on the river, he's going to end up having a better flush or a full house every single time. So on the one hand, we want to limit the size of the pot, which is very, very bad for our implied odds. On the other hand, even if we keep the pot small, we could still end up losing additional chips on the river. Hopefully we can see why this is not a very good spot for us. So this is an example situation where you need more than your direct pot odds. In other words, we have, let's say, 18% chance to hit. If we're being offered 18% pot odds by our opponent's bet size, that's no good here. If our opponent has min bet, and we're being offered 5% pot odds, for example, we only need 5% equity to call, then now we should seriously think about calling, but we should understand it's still not a great situation. Because although we can probably just about make it profitable, it's only just going to be profitable despite the fact that we get more than the required pot odds because we're going to lose additional chips on the later streets. So the key here to understanding this example is not necessarily the numbers involved, but understanding why this is a situation where our 5-6 of hearts carries reverse implied odds. And it's simply that even when we hit our draw, we don't know whether a hand is good or not. We don't know how many additional chips we really want to go in on the river. So anytime our opponent starts making big bets at us on the river, there is a possibility that we're actually losing money facing those bets. Now, if you've understood that example, hopefully this next scenario will make sense to you also. So it's actually a completely different type of hand, but it falls into the same category of hands which suffer from reverse implied odds. So once again, we're going to imagine that we are out of position on the turn. We face a second barrel. This time we don't have a draw, we have a pair. Now take a minute to think about this situation. Can you see why this is a hand that carries reverse implied odds? Now this is not really a hand that either hits or doesn't. It's already a made hand. The question is our pair of sixes good, or is our pair of sixes losing against our opponent's hand? Now the issue we have here is that even if our pair of sixes is good, it's going to be very, very difficult to figure out whether we can call a river bet in this spot. The other thing to keep in mind here is the price we get on the turn is not really our true price. Because let's say our opponent bets half pot, for example, so that means we're going to have 25% pot odds. Even if we had exactly 25% equity against our opponent's range on the turn, it would still be a mistake to call. Because we don't just get to call his turn bet and then get to fully realize the equity. The problem here is we call the turn bet, we're going to be facing a big bet on the river some unspecified amount of the time. And when you think about how easy it is to call a river with something like 6-8, well, there's going to be a lot of cards where we don't really like our life very much. Especially given that our pair is so low, especially given that there are straight draws out there, especially given that there are 2 flush draws out there, it's actually hard to think of a card that we like that much, aside from maybe something like a 6. Even an 8 could get us into trouble, because although it gives us 2 pair, our opponent can make things like straights and flushes on an 8 river. Even the 6 of clubs, which is probably the best card in the deck for us, could actually end up losing to something like pocket 7s, for example. But most of the cards are bad for us. It's going to be something like King of Diamonds, for example. Very, very hard to call a river bet. So what's going to happen is some of the time we're going to invest money on the turn. We're not even going to get to see a showdown because our opponent's going to make a big bet on the river. We're going to be forced to fold. Even if we do decide to call a river, we're going to be losing a large amount of the time. Hopefully you can see why we have reverse implied odds in this situation. Now, to help us deal with figuring out how much equity we need in this spot, we can make use of an adjusted pot odds calculation. Once again, this is something that some advanced players seem to completely misunderstand. Time and time again, I've seen players look at their direct pot odds on the turn. They've even gone so far as to pull up something like Equilab or Flopzilla, put their opponent on a range, then they look at their equity against that range, then they say something like, oh, well, I'm getting 25% pot odds and my hand has 26% equity. This must be an easy call. Well, it's really a shame that they've wasted their time putting all of that range into Flopzilla, etc., because they've completely misunderstood the situation. You can't just look at your pot odds in that scenario because you may be following up or be facing a river bet as a follow-up from our opponent some unspecified amount of the time. So what it really means is the effective pot odds we're getting are actually considerably worse than the direct pot odds that we are getting. So let's see an example of this, how we can apply mathematics to make slightly better estimates regarding how much equity we need with these vulnerable pairs. So we have a vulnerable pair on the turn, which doesn't improve very well. We've just seen an example of that. And let's put some numbers to this. So let's say there's $100 in the pot and we're facing a $75 bet. So what that means is we're investing 75 into a total pot of 250. So that means we get about 30% pot odds. So as we've discussed, we can't just look at this and say, okay, I'm getting 30% pot odds. Do I have 30% equity? Great, I've got 30% equity I can call. Doesn't quite work like that. What we can figure out straight away is if there's a possibility our opponent's going to be following up on the river and it's going to be difficult to call, we're actually going to need more than what our direct pot odds might suggest. So if we're getting 30% direct pot odds, we're going to need more than that. We're probably going to need something like 40% equity in order for it to be a profitable call in the long run. Well, how can we estimate that a little bit more precisely? And this is just an estimate, by the way. This is not precise maths, but it is important maths. You really want to actually be putting some numbers to this and making estimates. Let's just say that we anticipate that we will face a follow-up bet of $150. Makes sense, right? Because there's going to be a decent amount in the middle. There's going to be an extra 150 in the middle if we call. There's going to be 250 in the middle. If he bets 150, that seems to make sense. But let's just say we check his stats, for example, and he bets about 50% of the time in the river, and that's his standard sizing. It's not a difficult estimate to make. Well, if someone follows up with a $150 bet around 50% of the time, I would say that's roughly equivalent to someone following up with a $75 bet 100% of the time. So when we really think about that, we don't just call $75 on the turn and then get to see a showdown. We have to call 75 on the turn and then effectively 75 on the river. Although, of course, as we've seen, that's actually $150 some of the time, and we get to see a free showdown the other 50% of the time. We can equate that to being another $75 bet on the river. So in some senses, it's almost as if rather than betting $75, our opponent's actually betting $150 on the turn, because that's what we essentially have to invest on average in order to reach showdown. So rather than do a pot odds calculation with 75, why not just do a pot odds calculation with 150? That's going to give us a much better estimation regarding how much equity we need in order for this to be a profitable call on the turn. So let's see the maths on that. So we're not really investing 75 into a total pot of 250 anymore. Let's imagine our opponent's betting 150 into the pot of 100. So now we're investing 150 into a total pot of 400, because that's our 150, his 150, and the 100 that's already in the middle. So if you run the maths on that, 150 divided by 400, 37.5% pot odds. Now we really can compare that to equity. If we put him on a range, and we have a look at the equity of our hand against that range, and we have 37.5% equity, now we can make the call. But if we just have 30% equity, it doesn't matter that we're getting the direct pot odds. We have a hand that suffers from reverse implieds. We need to compensate for that by having better than the required direct pot odds. So you can see here we can estimate that to be roughly 37.5% pot odds. So this is not our direct pot odds. Our direct pot odds is 30%, but this is our effective pot odds. This is the actual effective price that we're getting on our cooldown here, because we know we're going to be facing that river bet some percentage of the time. So if we have 37.5% equity, we're good to go. But if we just have 35% equity, yes, we're beating our required pot odds, but we're going to be making losses in the long run. This is something that you can demonstrate quite easily using software. It's something that I do actually demonstrate here at pokerweasel.com, and it's in the video from the Fundamental Theorems of Poker series. That's video 7. By the way, the Fundamental Theorem series is an advanced theory series, so I actually think of the stuff we're doing right now as basic stuff. Fundamental Theorems is what I would consider an advanced theory series, and I actually demonstrate in Card Runners EV this idea of our effective pot odds as a result of the fact that our opponent can follow up on the river with some frequency. Okay, let's have a look at a pre-flop example now. And this was one situation which apparently was misunderstood by a high-stakes professional. The player in question, who I won't mention his name, but he considers himself to be the world's best heads-up no-limit hold'em player. And one of the things he mentioned live on stream was how if you get the direct pot odds pre-flop, then of course you should be calling. If you get the pot odds, you should always call. And difficult to say whether in this case this high-profile player was avoiding giving out information. Maybe he was deliberately saying things that were incorrect. Or it could just be the case that this very basic and fundamental principle has actually escaped this high-profile player. He doesn't actually know this. Maybe he actually believes that if you get the right pot odds to call in a certain situation, you should always call. Well, regardless of what's happening there, this is absolutely not the case, as we've seen in the video. There are many situations where you'll get the direct pot odds, but you should actually pass up on those opportunities because you suffer from reverse implieds. Conversely, there's situations where you don't get the direct pot odds, but you call anyway because you benefit from implied odds on the later streets. So I'd like to give you an example now. The example in question where this high-profile player was talking about how you should definitely call because you get the right pot odds was a pre-flop situation, and to me it looked like a bad pre-flop call in all reality. I don't remember the exact situation, but probably something along these lines. I think it maybe wasn't the hand I'm going to have, which is King-Queen suited. I think maybe it was a suited ace or something like that. But anyway, this is a situation. Button opens to 3 big blinds. We 3-bet to 10 big blinds in the small blind, and button comes back at us with a 4-bet. He 4-bets to 21 big blinds with a range of jacks plus and ace-king. Now, if we were to make the call here, and by the way, our hand is Queen-King suited, we would be investing 11 big blinds into a total pot of 43 big blinds. That means we're going to get 26% direct pot odds. Now, if I just put some of those numbers here into Power Equilab, very useful tool, by the way, something that you should definitely invest in at some point in your poker career. So one player has jacks plus and ace-king, and we have Queen-King suited. Let's have a look at our direct pot odds in this situation. Wow, we have a huge 29.33% equity in this case. So we actually get the direct pot odds in this spot. Next question is, should we call? We have the required equity, should we make the call? Now, interestingly, there's not enough information to answer this question, so before you start shouting yes or shouting no at your screen, we have to bear a couple of things in mind. Now, one of these is, if this is an all-in situation, let's say for whatever reason button only has 21 big blinds in his stack, then we get the direct pot odds. Of course, we should always call if we have the direct pot odds and we're facing an all-in bet from our opponent. That's just basic maths. We're going to profit in the long run. But let's assume that we're actually playing 100 big blinds deep. Should we make the call now? Well, the important thing here is that we must always consider our playability on the later streets. So we're out of position here. We have something like Queen King suited. Our opponent's range is Jacks plus and Ace King. We're going to have to play this hand out of position post flop in a 4-bet pot. So just think about that range for a minute, Jacks plus and Ace King. What are your thoughts on how Queen King suited is going to play post flop against that range? Well, to me it looks like a hand that's going to play very, very badly. What are the reasons? It looks like a hand that's heavily dominated and is going to suffer a lot from reverse implied odds. Because if we think about the hands in Button's range at the moment, Jacks plus and Ace King. Assuming that we hit the flop with our Queen King, either Button's going to have a hand that he's going to discard very easily, like something like Jacks, or he's going to make a better pair than us. Like we're going to flop a King, he's going to have Ace King, or he's going to have Aces, or he's going to have Kings. Or we're going to flop a King and he has Queens and Jacks and he's not going to give us any action. So we're in a situation where if we both hit, we're heavily dominated. We stand to lose a bunch of money post flop. If we hit and he misses, then we're just not going to get any action. Because maybe, for example, we flop a Queen, he has something like Ace King, he's not going to be paying us off post flop. So in other words, either he's going to be folding a lot when we hit, or he's going to have us dominated when we hit. So we can either win a very, very small pot post flop, or we're going to end up potentially getting stacked. So now all of a sudden, doesn't seem like a very attractive proposition for us anymore. Okay, we do just about get the pot odds pre-flop, but that's clearly not the only thing at work right now. Probably makes sense to fold in this example. Now, just to be very, very clear here, the point is not that you should fold King Queen suited against 4 bets. That's absolutely not the point here. This guy's 4 betting a range which is way too tight. And that may actually be a somewhat realistic range for some of the low limit games. Maybe at low limits you should be folding stuff like King Queen suited to a 4 bet. But there are situations where you might be defending that hand against a 4 bet as well. It depends on the range that Button is 4 betting, how much equity we have, but also whether we expect to have good implied odds post flop against that range, whether we expect to be dominated by that range. We have to consider our later street playability. In situations where we have reverse implied odds post flop, it doesn't matter if we get the direct pot odds pre-flop. We should be seriously considering making a tight fold on the current street, because our losses on the later streets are going to outweigh the fact that we get the direct pot odds. So hopefully you can extract the principles from this. The idea is not that we should necessarily fold King Queen suited to a 4 bet every time. The point here is, despite the fact that we get the right direct pot odds, because of our post-flop reverse implieds, we should be making a tight fold pre-flop. Alright, let's summarize the things you should be able to do after watching this video. You should be able to understand and be able to calculate reverse implied odds. This is something that you probably won't find in any other training video on the internet. I could be wrong, but let me just say it's very, very unlikely. I've been around for maybe 12 years or so. I've never seen a video on reverse implied odds and calculating them. I've never seen an article on it. I've never seen it mentioned in a book. I think people just assume because it's the same as implied odds, but in reverse, we can just ignore that. But now you should be able to specifically understand how to calculate reverse implied odds. You should, perhaps more importantly, be able to recognize common reverse implied scenarios. So we've seen 3 examples in this video. We've seen a situation where we have a dominated draw. It's either a non-nut draw or perhaps the board's already paired, so we could be drawing dead already. We've also seen a situation where we had a pair which was very vulnerable and didn't improve very well. So even if it had enough direct equity to get past its current street, it could potentially struggle to face big bets on the later streets. And as a result, it may sometimes be better to fold a hand directly on the current street. Now, based on that, we should be able to estimate the effective pot odds we're getting. So we know that we will have to face that follow-up bet with some frequency. We should be able to redesign our pot odds calculations to factor in how often we're going to face a bet on a later street and how big that bet will be on average. And the third scenario we've seen is a pre-flop one, where despite getting the direct pot odds pre-flop, we should seriously consider folding, because when we analyze the types of hands in our opponent's range, we can potentially get into a lot of domination issues post-flop, which will result in reverse implied odds. So despite getting the right price pre-flop, we should actually fold as a result of projected losses on the later streets. Alright, thanks very much for watching this video on reverse implied odds. Hopefully you enjoyed the video. In the next part of the series, we're going to be talking about dealing with probabilities. Next part of the series, it will be called Probability 101. It's going to talk about how we can use frequencies, how we can calculate various probabilities in order to improve our play at the tables. So look forward to catching you in part 5 of the series. Thanks for watching this video. This has been Weasel for PokerWeasel.com.